Students, I welcome you all to our channel of Future Focus. Today, we would be studying Chapter 1, Real Numbers of Mathematics of Class 9. So, let us start our session now. This chapter of real numbers is part of Unit 1, Number System. Okay? Now, we would be covering these 5 topics: rational numbers, irrational numbers, nth root of a real number, laws of exponents of integral powers, rationalization of real numbers. Now, first topic is rational numbers. So before understanding rational numbers, we need to understand first what is number line. So this is our number line, 0 in the middle and positive integers, that is 1, 2 and 3. These are on the right hand side. So right hand side we have positive numbers, right? And on the left hand side of 0, we have negative numbers. That is -1, -2, -3 and so on. So this number line is extended in both direction. So here also it is infinity and here also it is continuous till minus infinity. There is no end. So on both sides it is continuing, right? Now for understanding rational numbers, so here it is represented as P upon Q. Rational numbers of the form P upon Q. That means we can write it as 1 upon 4, 2 upon 7, 3 upon 5. Here there is one condition that Q cannot be 0. Let's say for example if Q is 0, 2 upon 0, 7 upon 0, 8 upon 0. That means all these three numbers, they are not defined in mathematics, or else they can be represented as infinity because there is no definition of numbers with denominator 0. Okay, so Q has some value other than 0. It can be anything that is on the positive direction of 0 or negative direction, doesn't matter. So now we would be understanding natural numbers. What are natural numbers? The numbers starting from 1, then 2, then 3, and so on are called natural numbers. If the numbers, next term is what are whole numbers? If I would be writing 0 before 1. So these are whole numbers. Whole numbers are starting from 0. Next, we will be talking about integers. All the numbers in the number line. All the numbers in the number line, whether they are negative or positive, both are called integers, right? So the combination of all these terms, like whole numbers, integers, whole numbers, and natural numbers. They are all called rational numbers, right? Where I already told you the condition is q cannot be 0. I hope you got this point very clearly in your mind. Now, we would be placing, we need to find the value of 1 by 2 in the number line. If I have to find out the value of 1 by 2 in the number line, for that purpose, 1 is divided into two parts. This is the total distance 1. It is divided into two parts. Half of this distance is 1 by 2, right? If I have to place 1 by 4 in the number line, 1 by 4 means 1 is divided into 4 parts. So, this would be your first part. This area. This area. This area would be your first part. This area second part. Then this area third part. Then this area fourth part. That means this would be 1 by 4. This would be 2 by 4. This would be 3 by 4. And this would be 4 by 4. So 4 by 4 is automatically 1. And 2 by 4 is automatically 1 by 2. Because 2 ones are 2 and okay. Now, if I have to represent, let's say for example, I have to represent 2 by 3 on the number line, right? That means we need to divide 2 by 3. This is your 0, this is your 1, and this is your 2. So, two by 3, that means first part 1, 2, and 3. So this would be 1 by 3, this would be 2 by 3, and this would be 3 by 3. So that means 1 is divided into 3 parts. So this is your 2 by 3. Okay, I hope you got this point, how to represent a rational number in the form of a number line. Okay, now I need to represent a rational number between 1 and 2. In fact, I need to represent 5 rational numbers between 1 and 2. So the formula is, let us take this as R and take this as S. The formula is R plus S divided by 2. Okay. So R is 1 and S is 2. So 1 plus 2 number would be 3 by 2. So first rational number between 1 and 2 would be 3 by 2. Now I have to find a number between 1 by 2, 1 and 3 by 2. Or I can find between 3 by 2 and 2, right? So number could be, this is your R and this is your S, and divide by 2. So 1 plus 3 by 2. 1 plus 3 by 2. That would be 5 by 2. 5 by 2 divided by 2, that would be 5 by 4. So our second number would be 5 by 4. Now let us find our third number. 5 by 4 and 3 by 2. Right? We have two numbers. This is your R, this is your S. So R plus S. So this would be 5 by 4 plus 6 by 4. That would be 11 by 4 divided by 2. That would be 11 by 8. So your next number would be 11 by 8. And so on, you can find out the numbers between two rational numbers. Now the representation of these rational numbers in decimal expression. The first case would be when your remainder is 0. Another case is when remainder is not equal to 0. Second case is when remainder is not equal to 0. So when remainder is equal to 0, that means, let's say for example, I'm taking the case of 1 by 2. That would be decimal form 0.5. And if I take 52 by 100, so decimal representation would be 0.52. That means these two decimals are terminating. They are terminating at some point like 0.5, 0.52. Now let us understand our second case when the remainder is not equal to 0. In the previous case, when I am dividing 2 by 1, so 1 is less than 2, I would be placing decimal and 0. 2 5s are 10. I don't have any remainder left. So when remainder is 0. Another case we would be discussing when the remainder is not equal to 0. Let us take the example of 1 by 3. We are dividing 3 with 1. 1 is less than 3. So again decimal and 10. 3 3s are 9. Again 1. Then again 3 3s are 10 because decimal we have already placed. Then 9. So this continues to infinity. So the decimal representation of 1 by 3 would be 0.3333 and so on. So it is continuing. So this number, that is 0.3 bar, that means when we place the bar with the number, that means it is non-terminating. It is not ending at any point, non-terminating. Okay. Now let us understand. So this is your exercise. You need to pause the video and solve these questions. If still there is any doubt left, you can ask in the comment section below. Our next topic is irrational numbers. When the numbers are not of the form p by q, when there is not this form p by q, then that number is known as irrational number. Let's say for example root 2, root 5, right? 1 plus root 7, root 3 plus root 2. Okay, so all these numbers are called irrational numbers. right? So if I need to represent an irrational number on the number line, how would I do that? So if this is your number line, I want to represent, this is your 0. If I want to represent root 17 in the number line, so let us split this as a square form. 16 plus 1, 16 is the square of 4, and 1 is the square of 1 is 1. So 17 can be written as 16 plus 1, 4 square plus 1 square. So that means square root of 4 square plus 1 square. So that means our hypotenuse would be root 17. And this would be your perpendicular and this would be your base. As we know from the Pythagoras theorem that when there is perpendicular distance, this angle is 90 degrees. This is your perpendicular distance, this is your base. So hypotenuse, this is your hypotenuse. Hypotenuse square is equal to perpendicular square plus base square. So hypotenuse would be perpendicular square plus base square square root. And this is our Pythagoras theorem. And I hope you have already started this in your 8th class, right? So same applies to root 17. Root 17 can be written as, similarly, root 17 can be written as 16 plus 1, right? Square root of 16 plus 1. Here 16 is the 4 square and 1 is square of 1. That means one term would be your perpendicular and one term would be your base. So here, how would we be representing it on the number line? If this is your number line and this is 0, and if this distance is 4 base and this is your perpendicular distance, sorry, and this is, I'm sorry, so if this is number line and your base is 4 and this is your perpendicular distance 1, so its hypotenuse would be root 17. This is how you would represent root 17. I suggest you to solve these questions of the exercise, and if there is still any doubt left, you can ask in the comment section below. I would be discussing one more question, that is find the different irrational numbers between two rational numbers. So this topic is left. I would be discussing this now. Let's say, for example, I have to find a irrational number between roots 1 by 7 and 2 by 7. The value of 1 by 7, if I divide it 1 by 7, I would get 0.14287, and it is non-terminating. And when I divide 2 by 7, I would be getting 0.285 714, and this is also non-terminating. So write any number, decimal number lying between these two numbers. Let's say, for example, I'm writing 1515 1 5, and this is also non-terminating, right? So this, in this way we can write irrational numbers between two rational numbers. I hope you got my point very clear. These two topics are clear to you. We would be continuing rest of the topics in my next video. Thank you all. Please do like, subscribe and follow us for more updates. Thank you.